Right. Hello, everyone. Thanks for coming. I'm Sokratis. I will be talking about how you can let your OpenSearch cluster monitor itself. Essentially, we'll see how we can enable OpenSearch cluster to monitor many aspects of itself without any external dependencies. So I've been working at CERN for the past 4 years and offering essentially OpenSearch as a service to the internal OpenSearch communities. Before, of course, it was Elasticsearch, but we have moved towards to OpenSearch now. For those not familiar, CERN is an intergovernmental organization that is doing research on fundamental particle physics. We are trying to answer interesting questions like what's the universe made of and how it works. To do that, we have built the world's largest particle accelerator. It's a 27 kilometers ring that we accelerate particles at very nearly the speed of light, and then we smash them together and see what happens. Now, we have 17,000 people all around the world collaborating for this purpose, and essentially we're trying to push the frontiers of science and technology together for the benefit of all, and also treat humankind's curiosity about these fundamental questions. Now, on the computing side, we are generating 1 petabyte of data per second. All these collisions have this huge amount of data, which of course would be tough to handle even for an OpenSearch cluster, so we are filtering down and we only store a fraction of it. And these are the interesting events out of the collisions. We store them in our data center at CERN, and this is part of a very large worldwide LHC computing grid, which is the computing grid consisting of 170 centers all over the world, and then we analyze and store about 200 petabytes of data every year there. And this is a grid that is being used, for example, for physics simulation jobs and anything that serves the purposes of our research. Now, back to our beloved OpenSearch service. We have moved from Elasticsearch to OpenDistro. By the way, how many of you have been around on the OpenDistro times? No one knows OpenDistro? Oh, very good. All right, and then to OpenSearch, which is, of course, what we offer right now. We have 125 clusters on version 2.15, and then there are still 9 legacy OpenDistro clusters there. In matter of storage, we index 800 terabytes of data, and that translates more or less in a 1.5 trillion documents across all our clusters. Now, why people use OpenSearch at CERN? Mostly it's for log analytics. Like for experiments, there are lots of applications that store their logs into OpenSearch. There are search engines like Zenodo or Inspire that are specific to the high-energy physics communities. And in IT, security is a big consumer of OpenSearch, let's say, monitoring, of course, and it's also part of the computing grid monitoring solution. All right, so what's the challenge today? What we're going to be addressing? We have a growing number of OpenSearch clusters. Everybody wants to put their hands on it and start working on it. So we cannot deny we are offering OpenSearch as a service, and we are creating more and more OpenSearch clusters. Now, no matter the wide variety of use cases that exist and we support, there are some things that are always the same. And that's some bad case practices that lots of users are doing in their OpenSearch cluster. And that leads to high resource utilization unnecessarily and suboptimal performance. Things like too big shards. So in our use case, having a half a terabyte of a shard or 1 terabyte of a single shard is not great. So another thing is a data node getting full. So this is essentially our user going over the agreed quota. Or too many shards stored in a single data node. again, depending on the resources that we allocate to that data node. So things like that we want to avoid, and we want to ensure that whenever that happens, the cluster will immediately realize and notify the appropriate people. I hate to say that part of this responsibility falls on the shoulders of our customers. And I can say that because I have only internal customers within CERN. So they are the ones pushing the data, consuming the data. It's usually on their side to get communicated about these problems. Of course, each one of them have their own communication channel. So some of them prefer email, some of them Slack. There's a diverse thing there. But with the help of alerting and notification plugins and nothing else, we are able to construct a solution very simple to tackle this problem and make sure that all the clusters will communicate to the right channel whatever problems arise. So let's dive into it. First attempt, we said, we have a monitoring cluster already running OpenSearch. Let's just use Logstash to query all the different clusters that we have and store the responses in this central cluster in different indices, and then create monitors on top of them, make sure to analyze the responses and create triggers for the 100 different notification channels, one for each cluster, in order to notify the appropriate people. Now, we hit a limitation that each monitor can only have up to 10 triggers, so this was not really moving forward, but even if we surpass this, the scaling was not really there. So we went for the second attempt, which is decentralized. And this is what we actually went forward with. In this case, every single cluster that we bootstrap comes with some default objects. And here we see the default notification channels that are based on the customer preferences. Again, can be Slack, can be email, webhook, ServiceNow ticket, whatever the customer wants. Hopefully, OpenSearch supports everything. And then, even more importantly, there are a number of default monitoring objects whose job is exactly to analyze all these common OpenSearch usage problems, and based on this analysis, if some thresholds are hit the notification button and send the alert to the corresponding channel. These are just some examples of the monitors. But we'll see right away. So we went forward with this. Now, the pros and cons, very quickly. There is no single point of failure. So even if the central monitoring cluster goes down, we don't care, because these alerts will keep on working. They are local to each OpenSearch cluster we offer. There's better scalability. We can grow to thousands of clusters without a problem. And there's no need to actually store the responses of those APIs. So we save cost here, let's say. And there is no external tools or dependencies to achieve this job. It's just native alerting and notifications plugins that come by default with OpenSearch. On the negative side, we have to maintain these monitoring objects all across our clusters. For example, if we have a typo in one alerting text, we have to go and fix it, update it on all the monitoring objects. But that's fairly easy with scripting, as we'll see. And then if the cluster is going down, if one cluster is going down, all these alerts are not working. But if that cluster goes down, you have bigger problems than these alerts. So it's important we also have on our side some external monitoring on the machine level, if there are hardware failures, on the process, OpenSearch process level, or even we have a remote probing to make sure that all our clusters are alive and running. All right, on the scripting side, all our cluster configuration are stored in YAML files. So the cluster name, the notification channels that they prefer, and also, very importantly, the flavor of the clusters. So some of them are tiny, some of them are huge. We do not allocate the same resources for all our clusters. So all this configuration is stored in a YAML file. And then we have 12 monitoring templates with placeholders. The placeholders are for cluster-specific values, like the cluster name, for example. And we'll see one of that. Or the notification channel. Again, it's different for each customer. And with Python, with simple Python scripting, we integrate all this together. And with OpenSearch Python library, we can easily create these objects upon bootstrapping the cluster. here's an example of a monitor configuration, the cluster health, which is an easy one. We use this very nice per cluster metrics monitor type. And what they do essentially is they allow you to run periodic API calls. So this monitor is running get cluster health. Another one could be for get node stats. You see the response over there, and then you can trigger conditions like if the cluster status is not green and it's yellow, for example, then send a notification to the appropriate channel. If it's red, maybe you have to send it to a different channel. You can play with that. And then here's how it looks, the JSON. Pretty straightforward. You specify the name and then which API you want to use, in this case, cluster health. And then there are some placeholders for the subject, saying, for example, the cluster name, or on the action side, the customer channel ID, and things like the shards number threshold, because as I said, some tiny clusters would have less of a threshold. Some big clusters would be able to support larger ones, so this is another calculated value. And then things like the endpoint, where we can call customer to do some action, and we can lead it directly to his or her cluster. So how it looks on the UI, simple notification channels on the corresponding cluster, and a list of monitors that come with it. And these, again, exist on every single OpenSearch cluster that we bootstrap. And they are able to analyze all the different APIs and the responses of them in order to make sure everything is alive, healthy, and proper values, let's say. So there's no suboptimal thing going on. So let's see some examples in order to better understand this. This is a simple one. So what I really like is that if a customer goes and stores many shards in a single node, we have a chance to explain it, first of all, saying, look, this number of shards are maybe too many. They capture space in memory, and your cluster is not ready to achieve this kind of performance. So this is your data nodes. This is the shards you store per data node, and this is the threshold that we recommend for you to store. So don't go over that because there may be some performance penalties. And then we can also call to action. So we can lead them directly to their index policies, saying, yeah, maybe you want to check your index policies if you're holding too much data, or maybe you have too many small shards, so you want to tackle this problem. We can link them to documentation, and then, of course, if in doubt, contact us. Another example for big shards, again, you can set your thresholds. In our case, if a shard goes over 80 gigabytes, we start a bit to struggle, so we have an alert based on that. And if somebody, as soon as a shard goes over, it would notify with the index name, saying that this is not good, and here's the index template you have to modify in order to overcome this. Zero replicas, something we are also afraid of. If a user of us creates an index with zero replicas, you know there is a risk of data loss in case of hardware failure. We don't like that. We explain it on the alert, and we say, here it goes. If you want to fix it, just do this call and set the number of replicas to at least 1. And maybe you want to check your index templates because you don't want to be setting by default replicas as 0. Another example for zero documents. Some of our users, for some reason, create an index and then do not populate it with documents. And that's a waste for the cluster resources. So again, we can simply say, these are empty indexes. So just go and delete them with this command. And, or if you believe they are necessary, maybe you want to check out if the retention is not good or whatever. And finally, a very simple example for cluster health. Again, if the cluster is found with yellow, you can send an alert. If a cluster is found with red status, a different alert, and then goes to the correct channel. All right, so as a summary, it was a fairly nice and easy solution that we found for for tackling this problem. It scales very well, no matter how many clusters we have. Still, a reminder, external monitoring is important because you don't want to base all your alerting on that, because if the cluster is down, your alerts are not working. Our customers have quite positive reaction on that. So they get informative alerts. They get a better understanding of how OpenSearch works because they read the text, and then we have call to action so that they can always quickly fix their problem before it gets too large. And the customers can trust that if they do something wrong, a timely alert will come to them saying, hey, you're doing something wrong, fix it. So our message to them is always, either you stay on the optimal path or you get alerted. So thank you very much, and I'm open for questions.